Just start recording. So two important aspects about this thing is three, in fact, three. When we're talking of theory of computation, three important aspects have to be considered. First is language. Second is automata. Third is grammar. Okay. If you are clear with these three concepts, these all three are just symbols, mathematical representation, abstract understanding of certain things which help us create the conceptual frameworks of any system. ठीक है, ये बहुत जरूरी है समझना. तो लैंग्वेज, ऑटोमेटा और ग्रामर, LAG बोल सकते हो, जो भी बोलो. अगर आपको ये चीजें समझ में आ गई हैं तो आपको थ्योरी ऑफ कंप्यूटेशन fairly you are able to understand. Then it all remains up to your practice of working with automata, creating grammars and all these things remain. ठीक है, अब सबसे पहले लैंग्वेज समझते हैं. लैंग्वेज, ऑटोमेटा, ग्रामर, ये चीजें समझते हैं. तो there are different understandings of language. First idea of language is high level language, low level language, assembly language. Yes? Do I need to explain to you what is high level language, what is low level language, what is assembly language?
No, sir.
No, sir.
Sorted, ना? तो इसमें आगे चलते हैं. ठीक है यार, ये WhatsApp पे डाल दो प्लीज, so that students can join. It's only 17 participants in the meeting right now. Why so less? ठीक है, तो अब लैंग्वेज में एक आइडिया और है, अंडरस्टैंडिंग थोड़ी और डीपन करने की कोशिश करते हैं, which is much more relevant to what we have to study. So number one is any symbol. So what is a language? Language is nothing but certain rules for using, which is used to communicate with the computer. Okay? Language is anything which is used to communicate. Either it is communication between people, or it is a communication between people and computer, or so and so forth, whatever it is there. तो भाई अब आपके पास लैंग्वेज है, तो लैंग्वेज का बेसिक बिल्डिंग ब्लॉक हम बोलते हैं symbol. ठीक है, symbol. So symbol can be A, B, C, and so on and so forth. It can be 0 or 1, or it can be anything. Okay. In our understanding, we will always look at only these two types of symbols: 0, 1, or A, B, C, or whatever. Okay. 0 to 9 भी हो सकता है. Like suppose your machine is a calculator, then calculator has the symbols which are 0 to 9, and certain mathematical symbols like division, multiplication, addition, minus, percent, etc. जो भी आपके these are what are called as symbol for that specific device or machine. ठीक है, क्लियर होगी बात. अब उसी वहीं से निकल के आता है input alphabet. So deriving from the symbols, we derive input alphabets, and the input alphabet is denoted by the symbol sigma, and it is nothing but finite set of, you can say set of finite symbols. It can be written as set of finite symbols or finite set of symbols. It means the same thing. Okay. So it can be written like 0, 1, or it can be written like A, B, or it can be written like A, B, 0, 1. So it means if your machine is bound by these input alphabet, either this or this or this or anything for that matter, then you cannot create any. Third aspect is string So now what is string? String is a sequence of alphabet. Okay, so using whenever an automata or a machine or a problem or anything is given to you, you will be provided with the input alphabet. So you don't have to worry about it. You will be provided with the input alphabet. You will be known. I mean, it will be given to you. So the input alphabet can be rearranged, rearranged, combined, recombined in different sequences. And one of those sequence is considered as a string. Okay. So suppose our input alphabet is 0, 1. Suppose we are talking of this input alphabet. So using this input alphabet, how many strings we can create? We can create multiple strings. 0, 1, 0, 0, 1, 1, 0, 1, 1, 0, 1, 1, 1, 0, 0, so on and so forth. If there is no limitation of any length or any condition or anything, then it is infinite in length, infinite in nature. I mean, you can create infinite number of strings. Yes or no? Yes or no, guys?
Yes, sir.
You can create infinite number of strings if you have been given a finite set of input alphabet. That is much clear. Up next idea. Now we come on to language. Now we come on to language. I'll take it to the next page. Now we come on to what language is. Language is nothing but set of finite number of strings, okay, based on some rule or condition. Okay, for example, suppose we have a language L. That language L says string of length 3 over sigma 0, 1. Now, what will be this? It is a set. It is a set, right? So how many strings can be there? 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. और क्या हो सकते हैं? Think of more. Can we have more?
बस
बस
सर इतने ही होंगे. Yes,
देख
sir.
लो एक बार. और हो सकते हैं क्या?
No, sir, इतने ही होंगे.
नहीं होंगे. तो ये हमारा
Sir,
हाँ जी
011 will be also there. ना?
हाँ होगा. वही मैं पूछ रहा था. मैं भी यार आप लोगों के साथ पूछ रहा हूँ. 011 हो सकता है. ठीक है. 101 हो गया. 011 हो सकता है. 110 कर लिया. 110 कर लिया.
Yes, sir. All done.
All done
हो गया सर. 8 ही होंगे. 2 power 3 होंगे.
वो 8 इसलिए हो गए क्योंकि it is
2 power 3.
2 power 3.
3.
बिल्कुल करेक्ट. तो आपको ये तो पता लग गया that given a length of मतलब given a formula, अगर आपको string length पता है and if you know the input symbols, then you can find out the language में कितने number of strings आ सकते हैं. आप language की length आप निकाल सकते हो, है ना. इतना तो आपको पता लग गया कि 2 to power 3 है, 2 to power 4 है, जो भी etc. ठीक है. हमारे लिए वो important अभी नहीं है. हमारे लिए ये for us the important thing is that that these are the strings which are accepted by this given language. These are the strings which are accepted by this given language. That's it. Okay, got it. So now this is what language is. Number one, is this clear to you? This is what language
Yes,
is
sir.
when we're talking about theory of computation. Language is nothing but a set of or a strings, collection of strings. Okay, collection of strings. ठीक है, सो ये हमारा ये बात क्लियर हो गई. अब एक एग्जांपल मैं पूछना चाहता हूँ आपसे. Because when we are discussing about language, I need you to experience different languages also. मतलब आपका एक एग्जांपल के तौर पे होना चाहिए. Just give me 1 second. Give me 1 second. Huh? Yes, there was. अभी हम actually work from home कर रहे हैं, तो कोई आया था. There was a doorbell, तो इसलिए. ठीक है. Now question is, I'm asking a question from you that length. It is string of any length, but they start from string of any length starting with 0, 1. So give me examples. क्या क्या हो सकते हैं strings?
0 1 0 0
0 1 हो गया, 0 1 0 0 हो गया, और
से तो इनफाइनाइट तक हो जाएगा.
हाँ 0 1 0 1 0 0 0 1 कुछ भी आप 0 1 के आगे you can write anything and it will create a language. ठीक है. So I will now rephrase the definition of language. So it is not set of finite number of strings. Your number of strings can be infinite. ठीक है. So we'll just rephrase this thing. It's just a collection of strings. Cool. Now, based on some rule or condition क्या थी? It should start with 0 1. Condition क्या थी? The length should be 3. ठीक है. Similarly, there will be many different conditions which can be given to you, and you have different languages. So this is, we call it L1. We call this as L2, or different languages. Is this clear? Is the idea of a language clear to you now, or do I need to ask some more examples so that it is clear? Okay. Cool. So now एक idea आया था. Mathematically, they wanted to come up with an idea of how to generate languages. I mean, not exactly generation of language, but a tool which helps to generate strings, which helps to allow us to generate strings, is called as Kleene Closure. Yeah, but this is also called as Kleene star. What is it? So the definition, the formal definition of Kleene closure is, it is the infinite set of all possible possible length strings, which are based out of sigma. So it is defined as sigma, or with an asterisk on top. This is how Kleene closure is created. Okay. It actually means sigma with the length 0 union with sigma of length 1, where we are talking of when we say sigma length 0 means any string which is of length 0, any string which is of length 1, with any string which is of length 2, 3 and 4. ठीक है, sigma length 2 union sigma length 3 and so forth. ठीक है, is this clear to you guys? Is this clear?
Yes, sir.
ठीक है, now another symbol that I'm going to introduce to you is sigma 0, which means length 0 is termed as null. दोनों में फर्क, both of them are different. This is called as a null. Okay, so clean closure or clean star includes all the possible combination of strings, including null. Okay, clean closure or clean star is defined as the infinite number of strings of any length, but also including null. So अब हम इसको हम लिखते हैं. Suppose sigma is 0, 1. So you'll have sigma star or sigma clean null 0, 1, 0, 0, 0, 1, 1, 0, 1, 1 and 0, 0, 0 और जो हमने 3 वाले की. ठीक है, are you able to get it?
Yes, sir.
Clear? समझ में आ गया? ये हमारा clean ऑपरेटर इसको बोलते हैं, clean closure बोलते हैं इसको. ठीक है, this is a very basic stuff called as clean closure. Okay, then there is another stuff called as positive closure. Positive closure, ये कुछ basic stuff है, कुछ पता होना चाहिए, क्योंकि देखो करिकुलम में है, ये आपको मैं इसलिए भी बता रहा हूँ कि बाद में 1 or 2 marks का कोई क्वेश्चन आ जाए तो ऐसा ना हो that you miss it. तो positive closure is nothing but clean closure minus the null. This is what positive closure is, and it is defined as sigma plus. It is defined as sigma plus. Clear? Is this clear? So it can also be defined
sir.
as sigma with length 1 union sigma with length 2 union sigma length 3 union so on. Okay, this is how we mathematically define clean closure and positive closure. ठीक है, समझ में आ गया? Languages आपको समझ में आ गई? Languages are also defined as finite language और infinite language. वो हमने देख लिया. ये वाली जो मैंने आपको बताई थी, this is a finite language and this type of language is an infinite language where the length is not considered. So I hope that is clear to you. ठीक है, समझ में आ गया? अब नेक्स्ट मैं थोड़ा जल्दी कर रहा हूँ बिकॉज ये बहुत ही बेसिक सा स्टफ था. आई होप दिस इज क्लियर टू यू. क्लियर, लैंग्वेज इज
Yes, sir.
क्लियर, alphabet
Yes,
is
sir.
clear. Anybody who has a doubt, please can ask. Anybody who has doubt? Amit, Poru, Anjali, Ayan, Priyanka, Rohan, Souvik. Is this clear to you guys?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good. Thank you so much. So now we'll discuss what is automata. I have discussed this with a little bit with a group. I don't remember कौन सा group था. कल कौन सा group था जिसका ट्यूट था, उनके साथ मैंने
Yes,
discuss
sir.
भी किया. जी वाह. But we'll discuss it again. Now, first of all, automata क्यों use करना है उसके बारे में दोबारा एक बार देखते हैं. Automata क्यों use करना है? तो हमने बात करी, we talked about something called as infinite languages, right? Infinite languages. Now, certain types are there, जैसे कि C language. Okay, Now, C language is what? C language can be, from our definition, जो भी हमने definition which we have seen, from the definition, we can see that C language is nothing but collection of all programs which can be compiled by C compiler. Yes or no? So it will be a collection of different programs. Program number 1, 2, and so on and so forth. How many programs are there which can be solved by which can be compiled by C compiler?
So infinite.
Yes,
Infinite number of programs.
infinite. So C language is a category of an infinite language in that aspect. In this, via this definition, okay? कहीं बाहर जाके बोल मत देना what is a C language? C language is infinite language. No, ऐसा बोल मत देना. You should not say it out loud. But from our definition, what we were discussing, C language can be categorized as an infinite language. And I hope that's it. That's it. That quite clear. Now, why do we need automata? Is that there are certain problems which we need to find out, that given a string, find out whether that string is accepted by the language or not. In fact, it's part of the language or not. Okay, so given a string, suppose we've got a string S, that string can be anything. So we have to find out whether that string is accepted by the language or not. This is a type of problem. This is a problem that we get. Okay. Similarly, given a program, you have to find out whether the program can be compiled or accepted by the C compiler or not. And ultimately, that's the idea of a compiler. The compiler will take input.
So
Yes.
So automata is basically like debugging.
And automata is basically like debugging. No. It's much more than that. It's not only debugging. It's more than that. So basically, automata is a. Give me just 1 minute. I'll just explain it to you. So if you have to find out that whether a string is part of this language or not, what you have to do is, one way is to find out all of the possible combination of the strings and put it in a set. So you create a language. You get all of the possible strings of a language and put it in a set. And then you try to compare the given S with one string, one element here, then the next element, and then the next element, and then the next element. So this is one idea to do, right? Now, how much is it feasible? Since the language is infinite, till how much longer can we go? We can check out 10 strings, we can check 100 strings, or maybe 1,000 strings, or maybe even 1 lakh. But since it is infinite, there is no end to any of the strings. So, it doesn't make much sense to find out all the possible strings and then compare it with the given string. So for this aspect, one of the utilization. So for this aspect, we utilize an abstract machine which can model the language. Are you able to get it? Abstract machine which models the language is automata. Okay. Now, what is a language? Language is nothing but all the rules stacked together, and based on those rules, you get some acceptable strings or non-acceptable strings. Yes or no? आपको समझ में are you able to get it or not? Or do I need to
Can you repeat once again?
Yes, Automata is nothing but an abstract machine which models a language. What is language? Language is any rule which allow us to accept some strings and reject some strings. Now, in our examples, we saw a very simple rule, string of any length starting with 0, 1. But I mean, in our normal understanding, we can have very complex rules. Yes or no? We can have many complex rules. We can say string of length 5 starting with 0, 1 but ending with 0, 0. This is a little more complex. Then we can have much more complex rules, just like a C lang, just like your language, which we are using as programming languages. They have too many rules. They have so many rules. So for those rules, we need to come up with the idea of different strings which can be accepted by that language or by that machine. So a language has to be represented by an abstract machine. Why do we call it as an abstract machine? Because this is not a machine like a hardware machine. It's a mathematical model of a language or a system which is there to solve some kind of a problem, or in other terms, accept or reject any string, any input, not string, accept or reject any input. Is this clear? Is this clear now?
Yes, sir.
Yes, sir.
So since we are looking at theory of computation talks about input, processing the input and giving an output. Now, if the input is not according to what the processor can understand, then obviously it has to give some kind of an error. Now, who tells the machine or the processor or the computation, the computer, that this is an input which can be accepted and this is an input which should be rejected? The idea is this theoretical machine or theoretical automata. इसको हम automata बोलते हैं. We call it as an automata. That's it. Automata means automatic machine only. Automatic machine. Automata is this only. So automata are of different types. First is your finite automata. Finite automata. Then you have PDA, push down automata. So in our curriculum, we will discuss only these two, but automata is only not limited to these only. Then you have linear bound automata and linear bound automata. And then you have very important is Turing machine. Have you heard of Alan Turing?
Yes, sir.
एक मूवी भी आई थी जिसमें
Yes, sir.
डॉक्टर स्ट्रेंज जो कैरेक्टर बेनेडिक्ट कम्बरबैच इज द एक्टर. हाँ,
Yes,
so
sir.
he has worked on Turing machine. He has actually he's playing the role of Alan Turing. So Turing machine उन्होंने बनाया. The Turing machine is like the basis of the modern computer. अगर आपको पता हो, अगर आपने वो मूवी में समझा हो इस चीज को, है ना, आपने देखा होगा.
Yes, sir.
Yes, sir. एनिग्मा को क्रैक करने के लिए.
एनिग्मा को क्रैक करने के लिए, ठीक है. तो अभी हम एनिग्मा जैसी बड़ी बड़ी बातें नहीं करेंगे, हम बहुत छोटी छोटी चीजें समझेंगे. उन्हीं चीजों को समझने के लिए फाइनाइट ऑटोमेटा एंड पीडीए को यूज करते हैं. ठीक है, इतना ही है हमारे करिकुलम में, हम इतना ही पढ़ेंगे, ज्यादा बड़ा काम नहीं करेंगे. ठीक है, समझ में आ गया? इज दिस क्लियर? Now, what is finite automata? We'll discuss this thing now. So, how do you define finite automata? वो हम देखते हैं. यार ये लेक्चर कितने बजे तक होता है पहले तो उस हिसाब से मैं बताऊंगा आपको.
11:20. 25. 11:25.
ठीक है, we have still 17 minutes. So, the meeting will end in another 7 minutes. So please join again. The same link. Now, finite automata. Suppose the finite automata is defined as a machine A. It is defined as mathematically. It is defined by tuples. There are 5 tuples. First is Q, second is sigma, third is delta, fourth is Q naught, and fifth is F. ठीक है, fifth is F. तो ये आपका finite automata mathematically is defined like this. ठीक है. Why we say mathematically? Because now we are talking of mathematical symbols and etc etc etc. Okay. So these are the 5 things. So what is Q? Q is finite set of states. States of what? Of any machine or any program or anything which we are talking about will have certain states. State means any situation in which a machine is currently is a state. That's it. Okay. Like for example, currently we are working from home, so that is our WFH state. If we have it is a blended class, then it is blended mode. If it is offline class, then it is offline state. So state is that finite set of state. Then what is sigma? बताओ, what is sigma? अभी हमने पढ़ा है finite set of what?
Set of input symbols.
Input alphabets, beta. Alphabets. We'll call it alphabets, not sim. I mean, yeah, symbols also, but majority it is also called as sim alphabets. Then you have delta. So delta is what? Delta,
Transition function.
yes, delta is the transition function. I'll explain what it is, just a minute. Then you have Q naught. Q naught is the starting or initial state. Just like when you start a game, it says na, initializing. So this is what it is. Then you have F. F is set of
Finite.
set of final states. Set of final states. Okay. Okay. Now, before we go on to transition, let's just understand why did we start with automata, or agar aap kahin pe, if you just read somewhere. So finite automata is majority, as I was saying, that we have to find out whether a language can accept a string or not. So essentially it is used to recognize patterns of string. Okay. So the major use, it is used to recognize patterns of string automata. Now, how does it do it? Let's just look at a diagram. Okay. So what, suppose I have this is what, an input tape or input strings on which we have strings. So we'll have strings 0, 1, 1, 0, 1, 0, whatever. I'm just giving an example. Okay. So this is my input. It is my input. Now, now what will happen is, this is my automata. This automata will have this thing is called as a read head. Read head. Okay. Read head. Now, what will happen is, automata will be in some state Q. It will read some symbol, which is either 0 or 1, and it will go to some other state Q. So QI and QJ. Let us just call them anything. So we'll just say Q this, Q this. This is transition. So on the application of one symbol, one input, our machine or the automata will transition from one state to another state. This is what transition is. Okay, this is what transition is. So transition, in our this thing, we are talking about transition function. So what is transition function? So transition function delta is defined as Q cross sigma will give me an output as Q star. Okay, sorry, not Q star, sorry, not Q star, it is only Q. किसी और में आता है, we'll just see. Okay, so what it means is that as an input, you need to have a state, you need to have an input symbol, and when you have applied a specific combination of a Q with some kind of a symbol, you will ultimately get another Q. This is how a transition function is defined. This is how a transition function is defined. Is this clear?
सर तो यहाँ पे जो QI और QJ वो दोनों सेम होगा?
नहीं. I mean, not necessary. They can be, they cannot be. It's not necessary. I and J can be same. I and J can be different also, but it is not necessary. It will be given to you. The transition state of a machine will be given to you, or you have to create your transition state on your own. I'll just tell you. So essentially, transition function.
So automata यहाँ पे क्या कर रहा है? What is
automata is the actual, देखो जब हम automata बनाते हैं, automata is the one which is the transition function. So the soul of the automata is the transition function only. जैसे हम बात करते हैं, for any program the main algorithm is the function. Function में आपने अगर लिखा है सही, then whatever you take as an input, whatever you give an output doesn't matter, but your function should perform the best. It should perform the actual algorithm जो होना चाहिए. If you are taking sorting as an example, data structure में sorting करते हैं, तो उसका algorithm आपका is the most important thing. Similarly, for any automata machine, the delta is the most important aspect of any machine, of your automata. So there are two things. You will be given two types of question. I'm just giving you directly question. Question will be of two types.